Hi, I'm Simon Marsland, Lead Chief Investigator of NESP Earth Systems and Climate Change Hub Project 2.1, Preparing Access for CMIP6. My DCI is Dave B here at CSIRO, as are most of our team based in the Aspendale site in Melbourne. We partner also through NESP with the University of Melbourne, with Roger Bodman sitting here in Aspendale with us. Access is the Australian Community Climate and Earth System Simulator. It does modelling across all timescales for Australian applications, from the numerical weather forecasts that the Bureau of Meteorology provide, through seasonal prediction, decadal prediction, and right up to climate timescales, which is the focus of our project. And it's a community model across the CSIRO, the Bureau of Meteorology, and the universities here in Australia, especially the 5 universities involved in the ARC Centres of Excellence. Access is an underpinning modelling platform, and what we're building is something that really underpins the climate challenges, all 5, that the hub addresses, and that's coasts, extremes, water, carbon, and ecosystems. Australia's always submitted models via World Climate Research Programme and CMIP, the Couple Model Intercomparison Project, that have delivered to all of the IPCC reports since the first one back in 1990. CSIRO has been involved in all of them, and the Bureau in many of them. Why we have a CMIP for every 7 years or so is because the science develops. So since CMIP 5, we've got better models, better physics, better parameterisations. We've got new science. So the World Climate Research Programme has 7 grand challenges addressing the new science. They're cryosphere, clouds, sea level, water and food, extremes, carbon, near-term climate. And it's a very nice synergy between the NESP challenges and those grand challenges. There are 3 CMIP6 science questions. How does the Earth system respond to forcing? What are the origins and consequences of systematic biases in our models? And how can we assess the future climate changes given climate variability, climate predictability, and the uncertainties in future scenarios? CMIP6 is a new experimental design. If you see the figure on the bottom left there, it portrays the CMIP design. It's like a dartboard. And what our project is trying to do is hit that thing in the middle. The deck is 4 experiments that every model in CMIP6 must perform. That's an atmospheric model intercomparison project, or AMIP, a pre-industrial control simulation, a 1% compounding CO2 simulation, and an abrupt 4 times CO2 simulation. Deck plus an historical simulation, which is from 1850 to 2015, and helps us verify the veracity of our model simulations. That is the entry level, and that's what we're trying to achieve. We're also committed to doing some future scenario runs for Australian needs. The research we undertake, we've taken the new generation UK Met Office atmospheric model, has much higher resolution in the atmosphere, 85 levels instead of the old 38 level model. It goes much higher into the stratosphere. The Cable Australia's Land model has made many science developments since CMIP 5, and we're incorporating those too. We also have updated versions of the NOAA Geophysical Fluid Dynamics Laboratory MOM Ocean model and the Los Alamos National Laboratory Sea Ice model. We couple these models. It's a huge task. We've got to make sure they're talking the same language and passing variables that are correct. We debug where we find problems, we tune the climate, we prepare the CMIP6 forcings for our model configuration, configure the experiments, and post-process for the Earth system grid. That's very important. That means all the models in CMIP6, 44 to 50 at this stage, are writing out data in common formats to facilitate the general global climate science community in uptaking and using this data. In this project, we plan to commence the data submission to the National Computational Infrastructure Facility in Canberra by the end of this month. We also plan to document and provide the model codes that we've built for standard experimental setups to give across the Access community so that scientists, students, postdocs can take up Access more easily and have benchmark simulations to work against in their science. So the main project outcomes are the modelling system, the international best practice that we hope to demonstrate through our CMIP 6 initial entry-level experiments. and the post-processing system. And we've already found a next user for our post-processing system here at CSIRO, with another group submitting the older version Earth system model with carbon cycling, etc., to CMIP6, and that post-processing system we're developing is proving very helpful to facilitate them as a next user in providing a second Australian submission. The model has improved aerosol, ozone, cloud microphysics, courtesy of the UK Met Office, although that's led to a higher equilibrium climate sensitivity. So what that means is that 2 times CO2 and then allow a model to equilibrate, we estimate that access will be up around 5 degrees Celsius, whereas in CMIP5, the models are in the range 2.1 to 4.7. As you can see in the histogram there, this is a emergent feature of CMIP6, which has come up recently at the CMIP6 workshop in March, where many of the new models with the advanced physics in the atmosphere and chemistry are finding a higher sensitivity. And that will be a challenge for our community going forward. Some of the benefits of this project: we provide the underpinning science platform that I spoke about. We benchmarked the model as world-class, or hope to. We found the next user in the Hub's Project 2.2 who are using our prototype version of CM2 with the UK's Jules Land Scheme already. Paper is in preparation there. And we give credibility to the climate model, and that really facilitates the uptake by the university community. So we already have 2 University of Tasmania PhD students sitting here at Aspendale using the model, and there's discussions going on across the university community of when they can get our CMIP6 codes. They're willing and eager to start experimenting with the more advanced model, which is great. We have great engagement both nationally and internationally as well with our research partners. We've made some good contributions to the Access Science Days. In fact, we've led the 2 that have been held over the 3 years of this project, and we hope going forward, as an outcome of last week's Access Science Day, that will become a much more regular thing, and we're already planning for around September at Bureau of Meteorology for the next one. We have strong alignment with COSMA, the Consortium for Ocean and Sea Ice Modelling in Australia, and that's a community across Australian National University, University of New South Wales, University of Tasmania, the NOAA Geophysical Fluid Dynamics Laboratory in the US, with Steve Griffiths tuning in each week, and the Australian Antarctic Division at those times where we're more focused on the cryosphere and sea ice. We also contribute to the UN partnership, especially through the Global Model Evaluation and Development Group and through technical working groups. And very importantly, we're ensuring that access simulations will be included in the IPCC 6 assessment report. The approach we're taking there, the IPCC has some hard deadlines. CMIP is running a little bit later than anticipated because at various times along the way, forcings came quite a bit later than they were expected to come. So about half the modelling groups are actually running a lot later than they wanted to. What we're doing as a community is that the IPCC chapter lead authors have put out a list of priority variables that will be used in their chapters and analyses, and that's where we're focusing our first efforts in processing the outputs of our CMIP6 simulations. Some of the achievements of this project: well, we've got great engagement with international bodies. I sit on the working group on couple modelling, which oversees the CMIP panel. The CMIP6 science, it's not something that's just going to stop when this project stops. It's not something that's going to stop when the IPCC report comes out next year. It's something that's bedded down for several years. There's a lot of work across those 23 modelling to comparison projects going forward. As with access in CMIP5, we find a lot of the recognition will come further down the track. So we have really great anticipated uptake in the 6 assessment report. Our next steps, we've got to complete the submission of our data to the Earth System Grid once the runs are completed. We are running our PI control, just about to start our historical and 1% CO2 simulations, or about 4 times CO2 simulation next week, and the atmospheric model into comparison project simulation is about to start today or early next week, and we'll be ready to submit by the end of the month. We plan some papers in the Bureau's Journal of Southern Hemisphere Earth System Science, JCS Special Edition. We feed directly into this project team into Project 5.1 starting next month. That's the access, evaluation and application. It includes people from both our couple model group and the Earth System Model carbon cycling group. we'll be doing ensembles, we'll be looking at improvements to the model, and we'll be looking to understand the higher equilibrium climate sensitivity in our model. We're also going to contribute to further CMIP6 intercomparison projects, or MIPs, going forth, the radiative forcing MIP, the flux anomaly force MIP, which looks at ocean heat uptake and sea level change, the ocean model intercomparison project, and the sea ice model intercomparison project. So thanks for listening, and if you have any questions, you have my contact details there. Thank you.